like, I don't know, makes it like no explanation of what's like
Sure.
happening.
Yeah.
So for like the here, let me go with the study guide thingy. Hold on, let me find where it is. Oh, here it is. Okay. And then so like for the study guide, like I like half of this stuff I do not remember how to do,
Sure.
which is like not great whatsoever considering we have a test in 2 weeks.
Yeah, no problem. So, I mean, I'll give you some ideas. I've helped with this class for many years, so I'm pretty familiar with it. Um, we're gonna go for about 30-ish minutes. Um, and then we'll talk about how to figure out a future schedule. This is tonight just to see if you like the format, if you're okay to do it virtually. Um, you know, Otherwise we can do some in person if we need to.
Okay.
All right, so let's get started here. I do jump off camera for the lesson, more for me than for anyone else. I do have the study guide up. What problem or problems would you like us to start with? What can I help you out with today?
I guess honestly, just start from the beginning and just kind of like work down as much as
Sounds
possible
good.
because like I just like I'm looking at some of this and I'm like, oh my goodness, like I remember doing this, I remember learning it, but I have
Sure,
no recollection. And my
sure,
notebook isn't much help because it's
sure.
just for problems.
Yeah. Okay, great. So it says, suppose the angle A terminates in quadrant two. So first thing is that you probably already know the quadrants, 1, 2, 3, 4. There's actually more than four when you get into the vector calculus. So there are four reference triangles. And believe it or not, it looks like a bow tie. You probably saw that in class. You have to know which quadrant you're in and which triangle to draw. You can't make up, it has to be this one of these four triangles. So in
Hmm.
this problem here, it tells you which quadrant you're in, so you don't have to worry about that. You want to draw that right there, quadrant two, and then secant of A equals -5/4. Now, I was never the kind of student where I learned a lot of formulas, but you have to know some. You have to know the reciprocal
Hmm.
ones here. Now, I put in the chat a reference sheet that I really like for this class. They call it a cheat sheet. It's worth printing out and having with you. It's got all the formulas for this class. I'll refer to it quite a bit.
Okay.
So they give you secant. Secant's not really useful, but cosine is. Secant's 1 over cosine. That's one of the reciprocal properties. And then maybe you're comfortable with the idea that if you flip the left, you flip the right. And then there's the question now of where to put the negative. We'll get to that in a moment. So in the reference bow tie in these four triangles, the reference angle is always with the x-axis, always, no exceptions. So in your problem here, this is A. So where does the 4 and the 5 go? Well, at some point you probably learned that cosine is adjacent over hypotenuse. So it's 4 and 5, but which one is negative? The hypotenuse is never negative, it's always positive. So this must be -4. And then you have to find the third side.
Hmm.
So to find that third side, you use Pythagorean theorem, a squared plus b squared equals c squared. Could you solve for that third side, or maybe you can just tell me what it is?
Yeah. So wouldn't it just be like off of like mental, hold on. Wouldn't it just be
Yep.
like three?
Is it three or -3?
+3.
It is because you're going up. So yeah, that's 3. Uh, all right. So now we have everything we need. So this problem could actually ask you for anything, a lot of things. It could ask you for, cotangent of A, tangent of A, anything really. It's just asking for tangent of A, which is opposite over adjacent, 3 over -4. There's your answer.
Okay.
Any questions, thoughts on that?
Nope, I think I am good.
So I know you said, hey, let's just go in order. But one of the things I can do, if you're like, hey, Matthew, I really need another problem like this, I'm happy to make up another one like this for you on the fly if needed. So
Okay.
just let me know if you ever feel like that you need another example.
Okay.
All right, number 2. Suppose cosecant of theta is less than 0 and cotangent of theta is greater than 0. Which quadrants could the angle terminate? Basically just saying which quadrant are you in? Have you
Hmm.
seen this acronym?
Absolutely not.
All right. So it stands for, well, there's a few variations on it. All students take calculus, which you may or may not agree with, but that's how people remember this. ASTC. So here's what it means. It means that all are positive in the first quadrant. So what do I mean by all? Like sine and cosine are positive, which means that tangent is positive because sine is the reciprocal of cosecant, and cosine is the reciprocal of secant. Tangent and cotangent are reciprocals. They're all positive in that quadrant. That's what the A means, all positive. And you already knew that probably, but that's what it stands for. In the second quadrant, sine is positive. Sine is positive. And it's kind of like a light switch. If sine is positive, then cosine is negative.
Mhm.
So what does that mean for tangent? Well, it means that tangent is negative because it's sine over cosine. Sine is positive, cosine is negative, and so on and so on. So this AFTC allows you to figure out which quadrant you're in because you can use these letters to figure out, well, which one's positive and which one is negative. So you're saying you did not see this in class?
Mm-mm.
Wow, that's terrible.
Yeah, it's pretty bad. Like literally the only reason I remember being like, why is it negative? And then I was like, oh, it's because it's in quadrant two and the x-axis is negative. Like, yeah.
There are some reference sheets that tell you, but like you really want to figure this out on the fly. You don't want to have to memorize this. So
Yeah.
cosecant is really like sine. So,
Hmm.
and actually let's do, and cotangent is really like tangent because they're reciprocals. So it's the positive one's easier. Where is tangent positive? Well, it's positive in the first quadrant because everything's positive. It's positive in the third quadrant because tangent is positive. That's what the T stands for. Okay.
Hmm.
Now cosecant is really like sine. So which quadrant is sine negative in? Now, if you remember that sine is the y value, that's another way to do it, but sine is positive here. If tangent is positive, that means that sine and cosine are negative. If cosine is positive, that means sine is negative. So it ends up being these two quadrants that
Hmm.
sine is negative, which cosecant is negative because it's reciprocal. So you know you're in quadrant 3.
Okay.
Any questions, thoughts on that?
No, I'm good on that one.
Okay, so how is your knowledge of the unit circle?
Um, I know like the coordinates that go to like pi over six, pi over four, pi over three, but like
So you know the
and
first quadrant pretty
I
well.
know like the special triangle for like some of them, and I know how to like do like reference angles somewhat. My teacher didn't really like explain like some of that stuff,
Yeah,
but I can like fudge it enough to do well. But like,
sure.
yeah, that's pretty much.
Okay, so like as just a side comment here, if you're going into engineering, you're going to take calculus 2 and
Mm-hmm.
you're going to need a lot of trigonometry in calculus 2. It comes up again in calculus 3. Um, it would be worth really getting this down.
Okay.
And there's a million videos on YouTube about how to do it. If you stare at it long enough, you'll find the patterns. We could certainly talk about that, but one of the things that you'll notice about tangent, and this is just one thing on tangent. Tangent covers this line, and this line, and this one has a slope of 1. This one has a slope of -1. So tangent is -1 at one of these angles.
Okay.
But, and there's a huge but here, and that's where I'm going to go back to that reference sheet quite a bit. Let me see where it is on here. The inverse, where is it? Maybe they moved it. I guess they moved it. I guess it is down there. So anyway, the arc tangent is good from minus pi over 2 to pi over 2. That's the angle that you're allowed to use
Mm-hmm.
for so you got to be careful. Like, yes, the answer would appear to be 5 pi over 4 or 7 pi over 4, but that's not the right angle. So with arc tangent, it's actually only defined on this part of the unit circle. So you would know it's that one, but it's coming counterclockwise from the origin. It ends up being minus pi over 4. And
Oh, okay.
that's what I'm trying to say. Like, that's why it's so important to know this unit circle. Like, if you
Mm-hmm.
want to, do well in these courses. It's that important, especially in this one.
Yeah.
And so like there's a million of these that I could give you, you know, a sine inverse of 1/2 or seek an inverse of 3 or something of 2, and you could be able to find them. There's a lot that goes into this. So tangent and sine have pretty similar arc sines have pretty similar. They're on this minus pi over 2 to pi over 2, but arc cosine is the exception. It's from 0 to pi.
Mm-hmm.
So like if you went to your calculator, and I don't know if you're allowed to use one, but if you were to type in arc tangent of -1, it would give you minus 45 degrees if your mode was in degrees. It
Mm-hmm.
wouldn't give you, so sometimes you gotta be careful that your calculator actually gives you what you want. Any questions on that?
I'm good. Thank you.
Okay. All right. And like you said, there's a lot of ways to use reference angles and stuff to find it. All right. Arc cosine, square root of 3. Arc cosine, square root of 3. So is there a place on the unit circle where the cosine of some angle equals the square root of 3? Does that
Uh,
exist on the unit circle? X value is the square root of 3.
I think so.
Yes and no, but it's the answer is yes. It's just not one of these nice values.
Yeah.
So what does that mean for us? It
Oh,
means
it's
that the
like,
question,
oh, I said, like, isn't it like one of those like weird like special triangle
we
thingies
have to
or?
draw a triangle here. So the you'd say let theta equal cosine inverse square root of 3, and then you take the cosine of both sides, which undoes the cosine inverse. So cosine theta equals square root of 3 over 1, and then you draw a triangle. And you say, okay, that's square root of 3, that's 1. You have to find the other side here. Could you do that for us?
Mm-hmm.
This, and we're doing the general case. You don't need all that for this problem, but that is
Oh, isn't that like, well, just like one of those like special, like a special triangle? So wouldn't it just be two?
um there's not two. Wait, is it? No, so I was hoping you, so the if you do the Pythagorean theorem here, right? A square root of 3 squared plus b squared equals 1 squared, you will see a problem. Kind of like
Oh,
nudging you
oh,
to
because of the oh, so it would be an oh my goodness, imaginary number.
right now here's why. Problem is that it kind of was deceptive there. This is not anywhere on the circle because the square root of 3 is greater than 1. So
Mm-hmm.
this actually is undefined. So this does not exist.
Oh,
So it's kind of a
I
weird that
see.
they would ask you that, but here's what I kind of heard from you, which is that there are two special triangles, the 45, 45, 90, and then there's the 30, 60, 90. That's what I was kind of hearing from you.
Mm-hmm.
Is that what you're referring to?
Yeah.
So yes, but those depend on the angles, not necessarily the side lengths. If the side lengths match up to this, then the angles also.
Okay,
So
I
just be
see.
careful there. Like this one, just because it's square root of 3 doesn't mean it's a special triangle.
Okay.
All right. Any questions on that?
No, that makes much more sense now.
All right. Where did my stepping tool go? Okay. Number 4 for A. So there is a recipe. I don't know if you like to cook, bake. There is a recipe here to determine whether functions are odd or even. So the recipe is you start by evaluating f of negative x. So you put negative x in for x, which gives you negative x cosine negative x. Okay.
Mm-hmm.
Is that all right?
Yeah. Sorry, I'm just like looking at this. I'm like, we did not do this in class and it's on a study guide. Oh,
All right,
goodness.
yeah. Yeah. Okay, so in that reference sheet I sent you, there's a bunch of these even odd formulas here. You might have already recognized that cosine, for example, is even because it's symmetric over the y-axis.
Mm-hmm.
Not drawn great. That's so cosine of minus x equals x. So this part right here becomes cosine of x. Okay. So here's the recipe. You start by putting negative x in for x. And if what you have at the end here, I'm gonna do this in blue, if this is equal to the original function, exactly equal to the original function, yes, no, is that equal to the original function? Exactly.
Uh, no.
It is not. If it was a yes, it's even.
Okay.
Okay. So that's thing one. Second thing you do is you factor out a negative one. So it's negative one times x cosine x.
Mm-hmm.
And then you look at the part inside parentheses and you ask yourself, is that the original function?
Yeah.
Yes, it is. So this is actually odd. Sorry, this is actually odd. So the first check, so the progression is it's either even, then you check for odd, then it's neither.
Oh, I see.
Or if you prefer like forks, I'm gonna have that as well. So
So if
this
you
one
were to
is
like,
this. Go ahead.
sorry. So if you were to like to factor it out and it didn't equal original equation, so then would it be neither?
Exactly.
Okay.
And in real life, most functions are neither. Just these functions in the classroom are, have some of this um, symmetry,
Mm-hmm.
but real life stuff is not as nice as they make it here. All right. So that's a little bit more than what it was asking me. They just asked whether it was odd or not. I mean, no, it's not odd, but you might be asked that it's even. That's where you got to be careful these study guides that you don't just study the one case. You want to study like what it's actually testing, which is it even? Is it odd? Is it neither? Okay. So cosecant. Also, this is a bad question because and you can actually tell your instructor, they should have specified the domain on this
Mm-hmm.
as well. Because these things, anyway, that's a side point. Don't, yeah, never mind. Um, so this is 1 over sine x. So you do the same thing. You first put in negative x. So this is 1 over sine negative x. And you grab your handy reference sheet with even odd formulas. We used to have books like filled with this kind of stuff. Now everything's on the internet. So if you don't
Mm-hmm.
want to print that out, take some screenshots or something, have them saved. So for
Mm-hmm.
sine becomes negative sine x.
Mm-hmm.
So the first check here is this exactly the same as the original, which is 1 over sine x? Is it exactly the same?
No.
No, it is not. So it is not even. Then you factor out negative 1, and you get negative 1 times 1 over sine x. And then you ask yourself, the part inside parentheses, is that the same as the original function?
Yes.
Yes, so it is odd. The other way to do it is to graph. And that's kind of what I was alluding to just now.
Mhm.
Do you use Desmos calculator? Are you familiar with that?
Yeah.
Okay, I really like it. I'd recommend, continuing to use it. So the problem with this, what I want to do here. Let me just show you this. All right, so where am I going? There it is. Okay. So I've graphed it here. Hopefully you're seeing that. Make sure. Yeah, you're seeing that right. The odd means it's got this origin symmetry. It's actually a rotation symmetry, 180 degrees rotated.
Mm-hmm.
Do you see that?
Mm-hmm.
Okay, so that's all these pieces are rotating 90 degrees. So a function like, let me get rid of that one. Uh, y equals secant x, is this one got you can see how this is even, it's symmetric over the y-axis, things like that. So the other way to do this problem, the problems you were given there, is to graph them. Um, sorry, I lost my place for where we were. What's the third one?
Oh, the
Arctangent.
third, yeah, arctangent of x.
Okay. All right. So what do you think? Is this one odd? Does it have
Yeah.
origin? Yeah, it is. So the other way is to just graph it. Now, is that the right way to do it? I mean, it's fine if it's multiple choice, but that is not the way it would be accepted.
Mhm.
Do you know if your final is multiple choice or your
It's like
yeah?
half part multiple choice, part free response.
Okay. All right. So actually, what we just did lends itself really, really well to question 5. Um, I'm not sure how much you have done with Desmos, but one of the really cool things about it is, if I get that back up, we can put a K. We can put a K there. You know about adding sliders? You seen that before?
I have not done that on Desmos yet.
Okay. So what's kind of cool here is you can sit there and you can play it, and it'll like show you what happens as K gets bigger, smaller, whatever.
Oh, I see.
So um, you can see though, um, and maybe you don't know this because you haven't seen it in a while, but arctangent is actually bounded. Let me put this back to 1. Arctangent. Whoa, let me get rid of that. So arctangent is actually bounded above and below by pi over 2 and minus pi over 2. So if I put a k in front of each of these, and then let's make k go from 0 to 5 maybe. All right. So we'll see that, that high and low points, that range basically is affected by the value of k. That's
Hmm.
probably enough. So you can see here the range is normally minus pi over 2 to pi over 2, but that k causes it to stretch
Hmm.
vertically. And so that's kind of what they're looking for in that answer. Let's go. I'm gonna grab a snip of this, put it in the other screen. All right. Okay. All right. So, what is the range? Well, you need to know that the range of arctangent is from minus pi over 2 to pi over 2. Actually, those are parentheses. And then the k basically influence it from minus k pi over 2 to k pi over 2, like that. Any questions, thoughts on that?
I am good on that one.
Okay. So where are we going from here? All right,
Um,
number 6.
yeah, we also did not do this one in class. I'm like, oh my goodness.
Okay. Yeah, like so the mistake as a student is you think, oh, it just undoes it. It kind of does, but not always. And it goes back to this whole like, well, where is arc sine defined? Which is, it's from minus pi over 2 to pi over 2. That's the inside one. And then, so where does it actually equal itself? So you could notice pretty quickly we're first quadrant, fourth quadrant, but it's really counterclockwise. So like, for example, here, if I asked you for the arc sine of square root of 2 over 2, you would know that that's pi over 4. And then the sine of pi over 4, the output becomes the input. Does that equal square root of 2 over 2? It does. Okay,
Mhm.
that's great. But now what if I want the arc sine of minus square root of 2 over 2? we're supposed to know that's minus pi over 4. Okay, that's down here. And so the sine of minus pi over 4 is minus square root of 2 over 2. Is that the same as that?
Yes.
Yes, it is. Okay, so it's working out. So you could make a conjecture here that it actually works in, you know, basically from minus pi over 2 to pi over 2. But you'd want to like test some values until you felt confident that it always worked.
Okay.
Does that make sense?
Mm-hmm.
Like it's more of a proof than anything. But what this is leading you to is like there'll be a question on the test where one of the answers will be X and one may not be X, and you have to know like, does cosine inverse of X always equal X? And that's, these are there's this one, there's the one for tangent. So you really got to know all of them.
Okay.
And that's pretty challenging here. I'm trying to find this reference sheet. I guess they read, oh no. Equals sine Y. So yeah, it's in this part of, it's on page 4. Try and pull it up here. So you can see top right here, top right. This is matching what you were given in this problem, top right. They're saying,
Mm-hmm.
hey, these all equal X. Okay, but you got to get the right range. Minus pi over 2 to pi over 2, 0 to pi. This question is really about you knowing this range of values, those 3 graphs that I made earlier for sine, cosine, and arctangent.
Okay.
Okay, maybe we could do one more problem here for tonight. Something else catch your eye there.
Can we try one of the simplifying on like 11, one of the simplifying the trigonometric expression?
Yeah, and we'll do more lessons. We got just want to make, before we go further, I'll make sure format's good and all that stuff. So yeah, one of the strategies for simplifying the expression is you obviously apply all your algebraic rules, like you're going to distribute. Okay.
Mm-hmm.
But when you distribute, like what does that even mean? Cosine, tangent, cosine, cotangent. I mean, that's not great. So
Mm-hmm.
the next strategy is that you need to you convert everything to sine and cosine. Okay, so like tangent is sine over cosine. Oh, that's good. The cosines cancel.
Mm-hmm.
And the cotangent is cosine theta over sine theta. So not as good, but that's okay. So we got this cancels with that. You get sine theta plus cosine squared theta over sine theta, like that.
Mm-hmm.
So another kind of algebraic strategy is to make a common denominator. What would the common denominator be in this problem?
It would just be sine theta, so it'd be
Right.
sine theta squared plus cosine squared over sine theta. Oh, so can't that like simplify to one? It would just be one over sine, which would be cosecant.
You got it. You did it. There you go. So that would be one of your multiple choice options on this. So the other kind of like, trick, there's not really a trick, but you could like graph this one and graph the answer, see if they're the same.
Okay.
All right. So let me go ahead and just stop here for